Welcome to Goldfish on Gaming, and the game you see loading before you is Atoms. Now, I'm not surprised if you don't recognise the name. That's because I made this game about 3 years ago, and this video is going to be all about how I went about making a game for a classic machine, because it was something I always wanted to do. Ever since I got my Spectrum, which weirdly I got it after my Amiga, I always wanted to make a game for it. It was one of those, I'm not sure why, but I know it's going to be fun to do. But unfortunately, I never got around to it. Just the wrong circumstances and situation just got in the way. And so when I discovered an SDK for developing Spectrum games on modern hardware but been able to target the classic machines, this passion reignited in me, and I just had to give it a go. Now, with any classic machine, hardware is king, and if you don't respect the hardware, you're going to be having a bad time. So let's have a quick look at what made the ZX Spectrum so special. To start off with, we have a 3.5 MHz Z80 CPU, which was actually quite fast for its time, significantly faster than the C64 for example. That was then paired with 48K of RAM, and then there's really nothing else. The only other chips on the board are ROM and a chip that basically reads the memory and draws whatever it finds on screen. It also handles keyboard and a few other bits and pieces, but there's no dedicated sound hardware, there's no dedicated video hardware. If you want to do scrolling, you have to do it with the CPU. If you want to play sound, you have to do it with the CPU. You want to put a sprite on the screen, again, it's you and the CPU, which is why that fast CPU was so important. With that 48K of RAM, we got about 40K for the game, which is actually quite a lot, but this means that we only have 6K for our video RAM. This is tiny, particularly when you think that the ZX Spectrum had a 256 by 192 resolution. This small amount of RAM gives us enough bits so we can have a single bit for every single pixel on screen, which effectively gives us 2 colours, so we can make some really nice black and white artwork. But we know this machine was capable of colour. You had at least 8 colours and then 7 more highlights. So how do we get from that black and white image to a full colour screen with only a few more K of RAM? Well, this is where the Spectrum's attribute memory comes in. For each 8x8 pixel grid square on the screen, we can set the page and the ink color, which defines the 2 colors each of those bits represents. Take our black and white image, and we can now see what it looks like with color. And we can very clearly see where these grid lines are coming in. This also is why the Spectrum had color clash, because you could only set 2 colors in these grid squares, and if you had a sprite or something moving between them, they would either have to write over what was previously there, or what was there would write over the sprite. All this was done for the sake of cost cutting, but it's quite a clever idea, and it's one that's going to define how I make this game. My thinking behind making Atoms for another platform was that I'd already done it for the Nintendo DS using the homebrew kit, the Xbox 360 indie marketplace using XNA, as well as the Windows Store, again XNA, and a few other platforms. So I already had some experience with the logic of the game, and I had artwork that I could use as either a basis or trying to import into some art program to use in the game. This meant I could concentrate more on trying to get the best out of the hardware than trying to design the game or trying to make graphics, and I feel that this helps quite a bit. Now, if you're not familiar with a game of Atom, then I'll give you a quick rundown. The idea is that you start with a 10x7 grid. Each player takes it in turn to put an atom down on that grid. You can place it on an empty square or on top of one of your own. If the number of atoms in a square is the same as the number of cardinal directions around it, then it will explode. This means 2 in the corner, 3 along edges and 4 in the middle. When it goes critical and explodes, it will send those atoms flying out and will take over any square it lands in, which will also include taking over and increasing the size of any additional atoms it finds from opposing players. This is key because the goal is to take over the entire board and leave no atoms from the opposing players left. As you can imagine, this will lead to some huge chain reactions and a lot of grid squares changing colour, but that's the fun of the game. And with this in mind, I had to make some decisions. First of all was how big I wanted the atoms to be on screen. I wanted them to be as big as possible, because it make it easier for players to be able to recognise how many atoms was in that square. But because of the colour situation, I also had to make sure that I only used the primary colours to differentiate each of the players. Because of that, I had to reduce the number of players down from the DS and Xbox version of 6 down to 4. Because we needed a background colour, we needed grid lines, and then we needed colours for the players. And once you added all those up, 4 was pretty much the maximum I could have without trying to do some nasty dithering or something similar. Now this is probably the only real compromise I needed to do. By aligning the grid to the attribute grid, I made sure that the graphics all lined up quite nicely. This included giving quite a bit of space for each individual atom. This is also very useful because it means I didn't have to update the grid all that often, only when I would move a cursor over it. Because one of the big problems with the ZX Spectrum is that you don't really have enough CPU time to update every single pixel and all the attribute grids on screen in a single frame. So the more that you can leave alone, the better off you'll be. This is why so many ZX Spectrum games had huge borders or big HUDs at the top or bottom of the screen, or some games literally just the name of the title. Thankfully, I didn't need to use quite such crude means. With the basics handled, it was time to start looking at development. Now I picked Z88DK as my development environment. This is because it allows me to write the game in C, which was useful as the DS version was also written in C. Now I didn't really pick too much code from the DS version and bring it over, but it was a good resource to look at to make sure I got the logic right. It also helped that I already knew C, and I didn't really know Z80 assembly. And to be honest, I still don't know Z80 assembly all that well. I picked up enough that I was able to write a few select functions that I needed in assembly code. The rest of it is more or less pure C, with a few macros to try and speed things up, where using stuff like divides and multiplication would be quite slow. Now Z88DK actually targets a number of different platforms, and unsurprisingly, these are platforms that actually run on the Z80 CPU, which includes machines like the MSX as well as the Master System. So those are machines I may have to have a look at some point, but I actually do have a new goal in mind at the moment that I'm working towards, and maybe in a couple of weeks time you might see a video on that. But let's get back to the Spectrum. I decided to write the game using Visual Studio as my development IDE, for the simple reason that I'm so used to working with it all the time, and all it took was a few scripts and I was away and going, and I could compile inside Visual Studio and it would show up errors correctly. It would allow me to jump to the right bit in the file when I made a mistake, and if I hit F5 it would start up an emulator and I was away. This meant I had a very rapid development cycle, and it helped greatly with trying to work out some of the weird and wonderful architecture of the ZX Spectrum, and the code came along quite nicely. This meant I now needed to start looking at making graphics. Thankfully we can also do all the graphics on our computer, and for the most part we can use all the modern tools we're used to, but at some point we're going to have to drop down to a very specific program designed for the Spectrum. Now there is a number of very well made ZX Spectrum paint programs, and these are designed in such a way to emulate how the ZX Spectrum works. So it knows about the attribute grid, it knows about the 15 colours that you can select. These tools also have lots of options for exporting, so you can pick the right one for the type of environment you're working in. Now Z88DK seems to be well supported within the community, which means that it's quite likely to be in the export options. Z88DK is also set up so it can import art in various different ways. This then led to quite a productive round of development. It then only took a couple of weeks to get something looking reasonably good and playing on screen. Once I got myself to that position, I knew my next step had to be testing on hardware, as there's nothing more enjoyable than seeing something you've made run on actual hardware. And for this I've used the Div MMC Enjoy flash card. Now this just takes an SD card, you then plug it in the back of your Spectrum. In this instance I'm going to use my Plus 2. Now unfortunately I need to do some work on this machine as the picture is quite ghosted, but it does the job well enough that we can see the game running, and it looks awesome. Now one area I've not spoken about too much has been audio. Now audio is not a strong point of the ZX Spectrum, particularly with the 48K variety that I was targeting as my base unit. You have that built-in speaker and that's about it. Thankfully Z88DK has some built-in audio effects, which made it quite easy to drop something in that would sound relevant to the situation, and I for the most part used those. I did look into what it would take to make some music, and it was so beyond my musical abilities, which are almost non-existent, that it seemed an impossibility. You had to set up so many very particular tricks with the hardware using assembly that I didn't think I could do it any sort of justice, and so I left it mute apart from the sound effects. The game itself ran in a couple of very basic loops. You started at the player select, you then transitioned into the game, then when you completed the game you were then at the winner screen and you looped back round again. The in-game logic is far more complicated. Started off with either your human player or the AI taking its turn. Once that had happened, the game would then check to see what atom had grown and would apply that to the game board. The game would then check to see if any atoms had exploded. If they had, it would mark those squares as growing and then repeat the main game logic. This would then continue until either no atoms exploded or it detected that there was no more players left on the grid. This was a special early out condition because it was possible for some very big chain reactions to never end, but it had taken out all the other players, so we would get out the game quickly. Normally from this step we would then check to see who should be playing next, or if there's only one player left, at which point we could then transition back to the main game loop, which means we'd go onto the winner screen to show who won. Thankfully for the most part this wasn't too taxing for the poor ZX Spectrum, and the game played quite quickly. Only with very large chain reactions with a lot of screen updating at the same time did we get any real slowdown. Now if you're actually interested in how the game was made, or if you're interested in making your own game, I actually put up the full source code for this version of Atoms and the Nintendo DS version up on my GitHub, and there'll be a link down in the description so you can check it out. This project helped me complete a lifelong dream of mine, which was to make a game for the ZX Spectrum, and was actually a lot of fun. Thankfully I already had a lot of skills that I could apply to this, but the actual application to a new platform that I hadn't really worked with before was really enjoyable. And if you know a bit of C programming, then I say give it a go. If not for the Spectrum, there is a number of other platforms with C compilers that you can give a go. I really am hoping that I can inspire someone else, because I think you might enjoy it. As usual, if you want any questions answered, leave me a comment and I'll do my best, or if there's any area you'd like me to go into far more detail, then I'd be more than willing to make another video. So until next time, I've been the Goldfish, and this has been Goldfish on Gaming.